In this video, we'll be solving polynomial equations by factoring. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c, where a is not equal to 0. We will be using the zero product property to help us solve equations by factoring. The zero product property says if a times b equals 0, then a equals 0 or b equals 0. And that makes sense. If two things multiply together and they equal 0, one of them's got to be 0. Our steps to solving a quadratic equation by factoring are, first, we'll distribute. Then we want to write the equation in the form ax squared plus bx plus c equals 0. Basically, we're getting it equal to 0 so that we can apply the zero product property after we factored. So once you get it set equal to 0, then you're going to factor the equation completely, apply the zero product property, and solve each resulting equation. Let's solve x squared plus x minus 12 equals 0 by factoring. We need to start by making sure our equation is equal to 0. It is. Then we want to factor that quadratic. We have a trinomial with a leading coefficient of 1, so we can go right to our parentheses with x's in first position. We're looking for two numbers that multiply together to give us a negative 12 and add to be a positive 1. Positive 4 and minus 3 work. Now that we're fully factored and we have two things multiplied together to equal 0, one of those factors has to be 0. Either x plus 4 equals 0, or x minus 3 equals 0. Now we solve the resulting linear equations. We get x to be negative 4 and x to be equal to positive 3. Next, let's solve 2a minus 1 times a minus 1 equals 6. The first thing we need to do is distribute the left-hand side. We're going to get 2a squared minus 2a minus 1a plus 1 equals 6. Combining like terms on the left, we get 2a squared minus 3a plus 1 equals 6. Next, we want to set our equation equal to 0, so let's subtract that 6 over. We have 2a squared minus 3a minus 5 equals 0. Now we want to factor the left-hand side. We have a quadratic trinomial with a leading coefficient other than 1. You can factor this by trial and error, or you can use the AC method, where we put a times c in the top of our x, b in the bottom. We're looking for two numbers that multiply together to be negative 10, but add together to be negative 3. Negative 5 and positive 2 work. We'll use these two numbers to strategically uncombine our middle term so that we can factor by grouping. 2a squared minus 5a plus 2a minus 5 equals 0. And then we factor by grouping. The greatest common factor out of our first two terms is a, leaving us with 2a minus 5. The GCF out of our second two terms is a positive 1, leaving us with 2a minus 5. We see that we have a common binomial factor that lets us know that we're on the right track with our factoring. So now we factor out that common binomial factor of 2a minus 5, and we're left with another factor of a plus 1. Now that our polynomial is fully factored, we can apply our zero product property and set each factor equal to 0 and solve. 2a minus 5 equals 0, and a plus 1 equals 0. So 2a is going to be equal to 5, making a equal to 5 halves. Solving the other equation, we get a to be equal to -1. Next, we want to solve the equation 3x squared minus 4cx minus c squared for the variable x. Even though there's multiple variables involved, our technique for solving is the same. Everything's all multiplied out. There's nothing to distribute. So next we want to set our equation equal to 0, and then we can factor it. I'm going to move everything to the left side of our equation. We're going to have 3x squared minus 4cx plus c squared equals 0. We have a trinomial with a leading coefficient other than 1. So just like in the previous example, we have the option to trial and error to factor or use the AC method. A times C in the top, B in the bottom. We're looking for two numbers that multiply together to give us a +3, but add together to give us a -4. -3 and -1 work. We'll use these two numbers to strategically uncombine this middle term. We'll rewrite this 3x squared minus 3cx minus 1cx plus c squared equals 0. Remember, when you're uncombining that middle term, you're not changing the variables at all. You're only changing the coefficient. Now we factor by grouping. The GCF out of the first two terms is a 3x, leaving us with x minus c. The GCF out of our second two terms is -1c, leaving us with x minus c. We see that common binomial factor that lets us know we're on the right track. Factoring that out, we're left with 3x minus 1c equals 0. We're fully factored and ready to apply our zero product property. X minus c equals 0, and 3x minus c equals 0. Remember, we're solving specifically for the variable x here. So in our first one, we'll just add c to both sides and get x equals c. In our next equation, 3x minus c equals 0, we'll add c to both sides and then divide by 3 and get our second solution of x equals c over 3.